Okay, we've defined a of x to be the integral from 0 to x of f of t dt, with f of x as shown in this graph below. So it's important to note, first of all, that this is f of x's graph down here, not a of x. All right, the other things to note, because f of t is on the inside here, and that goes from 0 to x, what that's telling us is that that is the derivative of a. All right, so I'm going to say the derivative of a is represented by f of x. All right, now we're asked when a is going to have local maximums and a is going to have local minimums, not the derivative of a. All right, so we're not looking for the highest point and lowest points on the graph below. All right, instead, let's think about this as, first of all, critical values. All right, critical values of a of x are whenever the derivative, a prime, equals 0. Or in our case, we can say that's the same thing as thinking about when f of x equals 0, because a prime of x and f of x are equivalent. All right, so because it's the integral going from 0 to x, we're going to ignore at 0 here. Instead, that's going to equal 0 at any x-intercepts. All right, y value of 0 on the graph, y value of 0, and y value of 0. So the only values we can list over on the right-hand side are 2, 4, and 6. We just have to pick out which one is, maximum, which one's a minimum. So this goes back to, if we think about the area underneath the derivatives graph, that's going to be the total amount. Whatever that area is the total amount of change for a of x. All right, being that that area was above the x-axis, a of x is increasing until we get to 2. So if it's increasing until we get to 2, that means at 2, we're going to have a maximum. All right, the next area we're looking at is between the curve and the x-axis. So because that one's below the x-axis, whatever that area turns out being is how much this is decreased, because it's below the x-axis. So it's decreasing until it gets to 4. And then we're back to increasing under that next one until we get to 6. So we'd say 2 and 6 are where we're going to have local maximums, and we're going to have a local minimum at 4. All right, the graph for A went up, down, and then up again. And at the end here, it was going to start going down again as well. All right, so I hope this helps out as you're trying to interpret A of x and this integral. Can be a little bit confusing as you're getting going on it, but just take your time.